Hello everyone, this is the next video on real analysis. So once we discussed a few problems on uh, functions of several variables, we discussed the differentiability in the last video. So this again moving further, we will try to solve few more problems on this particular uh, differentiability of several variables. See here I have one remark which says if the partial derivative fx and fy exists at the interval AB and at least one of them fx or fy is bounded in the given interval, then f is said to be continuous. If that partial derivative is continuous in that bounded interval AB, then f is said to be differentiable. Idea is clear? So you need to read in this way: if the partial derivative exists at AB and at least one of the partial derivative is bounded around AB, then f is continuous. Other result is if the partial derivative exists at AB and at least one of those partial derivative is continuous around AB, then f is differentiable. Idea is clear? So we have few problems here. If f is a function from r square to r, it's a scalar valued function such a way that he has given f, the partial derivative with respect to x is x square and the partial derivative with respect to y is y square. Then which of the following is true, we need to check. It is clear, it's not the options, we need to give which one of them is true or which one of them is false. So here since he has given the partial derivative as x square and the partial derivative as y square, I will choose fx of, so here fx is given to be x square and fy is given as y square. So he has given few options. In my mind I have one function f of x comma y equals to x cube by 3 plus y cube by 3. If I differentiate it partially, I will get 1 by 3 into 3x square. So I will get x square. Similarly fy, I will get y square. So if I choose this function, whether the option will hold or else whether these statements will hold. F is differentiable for all x, y in R square. Yes, this is analytic and it is differentiable since it's a polynomial, because in the denominator you don't have any zeros. Then f has directional derivative along I only along I plus j. We need to check this. And f has directional derivative, f does not have directional derivative anywhere. See here, if f is differentiable, then this implies f has directional derivative along all the direction. So this function is differentiable. So this option is false. Then again, only along I plus j, this is also false. So if is differentiable, that is true, then it has directional derivative in all the direction. Idea is clear? Next question is asking, again it's a scalar valued function. F from r square to r be a function such that f of x comma y is lying between 0 and x square plus y square for all xy, for all the elements of the domain. The function is defined to be this, and modulus of the function is defined to be this. Show that f is differentiable at origin. See here, he has not given what is the function, he has given just the value of the function. In that sense, we need to find what is a. That is, in fact, f is said to be differentiable if f of x plus h comma y plus b y plus k minus f of, you say, a comma b equals to a into h plus b into k plus square root of h square plus k square e of h comma k. And this is differentiable if e of h comma k tends to 0 as h comma k tends to 0 comma 0. So a is given to be 0, b is given to be 0 because he is asking f is differentiable at 0 comma 0. So it is f of h comma k minus f of 0 comma 0 ah plus bk plus h square plus k square e of h comma k. But we need to find this a and we need to know what is the value of this. See, since that f of x comma y is greater than or equals to 0 and at 0 comma 0, look to this, it is less than or equals to 0. This implies f of x comma y is 0 at 0 comma 0. Idea is clear? It's both non-negative. So at 0 comma 0 it is less than, this means it will be between 0 and 0. So modulus of f of x comma y must be 0. So it implies this should be 0. Artha agatalva? So that means this is 0. But we need to find a. What is a? A is fx, which is the partial derivative at 0 comma 0. So limit of h tending to 0, f of a plus h comma b minus f of a comma b by h, which implies limit as h tending to 0, f of a plus h. Look to this, a is 0, b is 0, so h comma 0 minus f of 0 comma 0 by h. So here he says this is 0, f of h comma 0 by h. So you can write this as f of h comma 0 by h, limit as h tending to 0. Take the modulus of a, and the modulus of a is greater than or equals to 0. That is less than or equals to f of h comma 0 is here. So if you consider f of h comma 0, it is limit as h tending to 0 h square by h. So this is as h tends to 0, this is equals to 0. So this implies a is, so a is equals to 0. So a is 0, similarly b is also 0, you can show. So if a is 0 and b is 0, you plug it here. So you will get error function e of h comma k is f of h comma k by square root of h square plus k square, and say the modulus. See, we don't know exactly what is the value of this f. That's why we are always trying to approximate. Since we know what is the value of f of x comma y, it's lying between 0 and x square plus y square. So this is less than or equals to h square plus k square by half, which is h square plus k square within the square root, and this tends to 0 as h comma k tends to 0 comma 0. In the sense, the function, error function e of h comma k is tending to 0 as your x and y tends to 0 comma 0. Idea is clear? So the function is differentiable. Second question, what else it is given? It's solved. Third one is f of x comma y equals to x square plus y square whenever x and y are rationals. Whenever they are not rationals, it is given as 0. So whether this function is differentiable. If it is differentiable, at what point it is differentiable? See, you equate this likewise as we discussed the Dirichlet function. So x square plus y square equals to 0. This if and only if, right, x must be 0. So f is differentiable at 0 comma 0. Again, fourth question, if f of x comma y equals to 1 by x square tan inverse of x by square root of x square plus y square plus x to the power 10 by y to the power 12 e power x square by y square, where x is greater than 1 and y is greater than by y2, show that x fx plus y fy is minus 2f. See, we have one result. First of all, we need to study what is homogeneous function of degree n. See, f of x comma y is said to be a homogeneous function of degree n if f of lambda x lambda y equals to lambda to the power n f of x comma y. So we use that definition. X into fx plus y into fy is minus 2f. So first thing is homogeneous function is over. Then we have one standard results which says if f is an homogeneous function of degree n, then x into partial derivative with respect to itself plus y into partial derivative of x, partial derivative of f with respect to y itself, that is equals to n into f of x comma y. Now here the function, if you plug in what is lambda x and lambda y, you will get lambda to the power minus 2 into f of x comma y. Check this. In the sense the function is a homogeneous function of degree minus 2. N equals to minus 2 here. So here you will get x into fx plus y into fy equals to lambda into f, where lambda is minus 2, sorry, n is minus 2, n into f. N is minus 2, so you will get minus 2 into f. Idea is clear? So it's an homogeneous function of degree 2. So you will get minus 2 into f. A degree n ಬರುತ್ತೋ homogeneity n ಬಂದಿದೆಯಲ್ಲ ಇಲ್ಲಿ minus 2 ಬಂದ್ಬಿಡುತ್ತೆ. Idea is clear? ಇಲ್ಲಿ ಏನು ಪವರ್ ಬರುತ್ತೋ ಅದು minus 2. ಚೆಕ್ ಮಾಡಿ, ಇದು minus 2 ಬರುತ್ತೆ. Thank you.